Hello everyone, I'm here at NVIDIA GTC and I talk to tech CEOs around the world.
As a company, we don't do backflips or dancing. We are here to do real work.
Being able to do the parallel processes and the billions of calculations that are required.
So it's like an exoskeleton upon your hand.
No one needs to risk his life. It's very simple.
But also, how do they take advantage of AI with their existing data centers?
That is why I started Humanoid to free people from dangerous, hard and repetitive tasks.
Who are you? Where are you from? And what are you doing?
Hi Lara, nice to see you. Thanks for the invitation. My name is Vasilapostolos Ouranis, born and raised in Athens, Greece. Now living in Amsterdam, Netherlands.
Beautiful.
Trying to solve a global, let's say, problem or challenge. So I'm CTO at Haptikos, where we are trying to transfer the dexterity from the human hand to the robot hands. So how we do that?
Yeah, how do you do that?
Yeah, so initially we have identified that the capture of the emotions and the multimodality from the human hand is not there. So that's why we have created a wearable device that can provide and extract or decode the human hand. Mm-hmm. So that includes motion tracking from 24 degrees of freedom of the human hand, capturing almost every hand joint, along with contact cues. This means that we can see the intent from the force that the human hand applies to objects and the tactile feedback notifying the user that is touching something.
So, but like, do I wear something
Correct.
on? I have a glove, right? It's
like an exoskeleton.
Yeah,
it's more like an exoskeleton, but it can be like a glove, yeah.
But so, and then I steer the robot's hand from somewhere else.
Correct.
Okay, that's crazy.
So it's like an exoskeleton upon your hand.
Okay.
And there are 5 contact points on each finger,
Yes.
along with the strap on your palm.
Okay.
So in that way, we have a mechanical based tracking based on like encoders that we can create inverse kinematics based on your motions of your fingers. Mm-hmm. So that's why we can decode the whole motion of your hand. Along with that, as I said, we have DC motors that, as you said, when you are teleoperating a robotic system,
Yes.
like a robot hand, the robot from the other side, they do have sensors, like
Yes.
pressure sensors.
Yeah.
So you can create a connection between the signals from the robot to your hand.
Wow.
So you get the feedback that the robot
It goes
has,
both
the
ways.
experience that the robot has comes to your hand.
So if someone is like clapping hands with me, you would feel that?
Yeah, if 2 robots, let's say, like 2 humanoids
Yeah,
down the road.
Yes.
Yeah.
But is it just a use case for humanoid robots, or because I thought about, virtual experiences, this would also work,
Yeah,
right?
of course. Our solution acts like an input device
Yeah.
to the whole physical world, but also, as you said, in the physical world, like robots. Of course, there are use cases in industrial environment for manufacturing,
Yes.
also for, as we said, for humanoids down the road or when we automate. But the idea from our side is that there wasn't information about the human hand. So how we can decode the dexterity that our body hides.
Is that something that is unique about your company, that you have found that?
Yes. So we started from a hackathon back
Wow.
7 to 8 years ago. So
Okay.
it's been a long. But back then it was for the European Space Agency. So
I work closely with them.
Yeah,
That's cool.
sure.
Wow. And so you found that?
So yeah, there was the challenge of technology transfer.
Yes.
So how we can exploit technology for the space in Earth applications.
Yes.
So that's why we saw that electromagnetic sensors can provide us an opportunity to create something like a glove back then with this type of sensors as a base technology in order to translate emotions from your hand into voice for sign language.
Wow.
But actually, there was some challenges with the technologies back then because for sign language, you need also facial sensors to get information from the facial motions. So that we have to pivot. We went through XR applications, virtual reality, as you said, like doing virtual training, having your hands there instead of using controllers.
Yeah.
But with the rise of AI and robotics, we see that this technology can be a great fit to the future of robotics.
If someone touches something in the factory that is hot, is that something you feel somewhere else?
You could if you
Okay.
have also temperature sensors.
Okay.
But the idea how we exploit our technology, real examples, is that we follow pipeline of generating data from real
Yes.
to sim to real.
Yeah.
What that means, back in the days when someone was trying to automate a robot for performing dexterous tasks, so specifying on robot hands, mainly they use simulations. But in simulation, you cannot simulate all physics elements.
Yeah.
That's why we identified that starting from the real world, so what that means,
Yes.
you teleoperate a robot performing a task, solving a puzzle or a sorting task, having all these degrees of freedom, getting the multimodal data from this interaction, as you said. So collecting episodes from this task that we are performing, several episodes with, let's say, with different angles or ways to grab something.
Wow.
So you create like dots that the simulation is gonna connect them.
Wow.
So we use this data on NVIDIA Isaac Sim in order to, based on this ground truth, to create new data sets that can connect the dots, so capturing all possible ways that the robot is going to deal down the road.
The glove is not the future, right? Data is. Is that the way? Like, we won't have gloves in the future. We collect data for simulations, and is that the only future of your company, or are there like multiple?
Yeah, as you say, I think the future is the data. We can say that it's the ChatGPT time for robotics, let's say. Back in the days when all the LLMs were trying to be valuable for their audience, they didn't have data that can provide satisfying results.
Yeah.
The same happens in physical AI space at the moment.
Yeah.
So as you say, there is this procedure that we have to collect all this data that down the road it's going to be the ground truth for robots to operate along with people and humans.
Wow. Wow, okay. And you already mentioned how you collaborate with NVIDIA on those simulations. Like, tell me a bit more about your collaboration.
So, as I said before, we have the teaching by demonstration, like teleoperating a robot, but you can accelerate the automation of the task that you want to record, like with the episodes, creating a simulation on Isaac Sim. So what that means, if a company, let's say, wants to automate a sorting task in their factory, they can have a physical setup of the operation via teleoperation, but they can create that on the Isaac Sim side.
Yes.
Why that? Because, of course, you cannot say to someone to set up several physical setups of the robot, but if they have the opportunity to do that with zero cost, let's say, on the simulation and having engineers collecting data, they can accelerate the automation of this task.
Yeah.
So that's why we take advantage of the simulation, having as the template the physical data from the physical simulation, and then we use the GROOT model for policy making. So what that means that we provide this data from the simulation, but also from the physical setup to the GROOT model from NVIDIA in order to fine-tune the automation of this task.
Well, that's smart. That's so smart. And it seems like everything is working. What are the big challenges you are currently facing?
Trying to create a solution that combines hardware and software is by default a difficult task from the people that you want to hire, a multidisciplinary team. But I think the most challenging is that you are trying to create a haptic solution, so a wearable for the human hand that is going to decode the human dexterity. Trying to minimize all these mechanical systems, sensors, actuators, in a way to fit on your hand is pretty challenging.
Yeah, I can imagine. So maybe you can finish the sentence. The problem you solve in the world is?
Making robots to feel like humans.
Wow. Thank you so much.
Thank you.
Thank you.